Welcome back, guys, to the Code Show. This is Hafiz, and today we are going to resolve palindrome partitioning problem on Leetcode. So first, we are going to explain the problem, and second, we are going to digging down to the code level. So, but they are expecting to get input as a string like AAB, and then they are expecting to substring this partition or this string to a small palindrome partitions. So we are going to decompose or substring the main string to a small shrinks or a small chunks or whatever partitions, but should be a palindrome partition. So we're going to explain first the expectation from to imagine how we can substring our string. All right. So in this example, we got AAB. So we're going to substring first A, and this A, it's a valid palindrome. Yeah, it's a valid palindrome. Then we are going to substring the another character. It's a A, so it's also a valid palindrome. And we will end by B. It's a valid, also it's a valid palindrome because every little element in this string, it's a palindrome. So A, it's a palindrome, it's a valid palindrome, and A and B. Then we are going to back because we are already in a backtracking function. It's a backtracking problem. So we are going to back to increase our substring to check it's valid or we can create another palindrome partitions or not. So for example, or in our code will behave like we'll take A and B because you are backing from the last level, so we are getting B and A. So we increase B and A. So it's a not palindrome problem. So we are going to ignore this result. We are going to eliminate or ignore the non-palindrome partitions. So we're going to ignore AAB and we'll increase or eliminate B and take A and A. So it's a valid palindrome partition for me. So we're going to take B standalone. It's already a palindrome substring or a palindrome partition for the code. So for now, we got the two results that we are looking for. So, or the problem looking for. So AAB, it's happened, and AA with B, so it's already happened here in our solution. And last thing, we are going to take the full string uh, together, the four element together. It's not a palindrome substring, it's not a palindrome partition for the code. So we are going to ignore this result also. So we are going to pick just the valid palindrome partitions or valid palindrome substring elements. So let's digging down to the code. But before we are going to dig down to the code, we are going to create two functions. The first function is the DFS or our backtracking functions. The second function, we are going to create a function it will be responsible for detecting if this element or this substring it's a palindrome or not. So we will name it is palindrome. It's a Boolean function, palindrome or not. So that's it. We get these two functions. Let's dig down to the code. First, they are expecting to return a substring, a vector of substring of strings. So we're going to name it, define a container as our big result, and we're going also to define our the result itself that we are going to inject or inserting it inside the container. And for sure, we're going to return this container. Also, we are going to call our backtracking function to build, or our backtracking function to build this substring. So we are going to start by 0, 0. This is our element or our pointer that will be responsible for looking for each element inside this string. So we are going to first define our void DFS function, and this is our pointer or our position, and this is our items. Items here, it is a string. This is a string, but we renamed it to items. So this is pure recursive backtracking function. So we have to plot or have to determine our base condition. So our base condition is when the position is equal items dot size. This is our base condition. So if this base condition happen, we're going to push inside our container to push back the result. So let's build this result in our recursive function. So we're going to define, we're going to create a function, or sorry, a for loop to iterate over every element inside this string. So first, we're going to define. It's looking weird, but it's not. We are not just. We are going to start from this position of 0. We're going to from this position to avoid the duplicated result and to prevent any infinity loop. And we're going to continue if I lower than items dot size, and then we're going to increment this I plus plus. Then we're going to this is our loop, and that we are going to looping over each element or each string, each character in the string. So we need to do substring for partitioning inside a partitioning process. So we're going to define a variable. We name it a string. We name it temp. So we're going to substring this items to starting from position 0 or whatever position until I minus position plus 1, and that's our trick sorry, our trick part that we are going to substring. We are going to start substring between range. So this is our part. In this part, we are going to partition our substring by range. So starting if the position equals 0, so an I equals 0, so we are going to pick one element, because so we incremented, we added plus 1 here. So we are going to take A, and in the second iteration we will take the second element will be A, and the third iteration we are going to pick B. So, and in every iteration this range will be increased to get the full string as we explained here. So we're going to pick only if this temp is a palindromic temp or not. So this is our big scenario that we are going to pick if only we have if only the stem is a palindrome substring or a palindrome partition. So let's define the palindrome partition first function. So it's a Boolean function. We'll take the string temp, and what's the palindromic function we're going to do? For example, let's first take level as a temp as a variable. So we are moving to using a 2 pointer. The first pointer is looking for the first character or first element in the string, and and the last pointer is looking for the last element in this character. So we're going to move and we're going to iterate over this string using a two pointer. In this two pointer, in every iteration, we are trying to make sure that the last element or the right pointer is equal to the left pointer. So we're going to decrease right pointer and increase the left pointer to look to the second character if it's already equal, right? So is a palindromic. So if not, we will return false. So let's determine our left pointer is equal 0 because we are starting from the beginning, and the right pointer is equal to temp.size -1 because we are looking for the last pointer, the last characters. The last character, yeah. So we're going to loop if left is lower than right, lower than or equal right. Okay, and this condition to prevent any overlapping, uh, to prevent any overlapping here. So to prevent also any infinity loop, and we are going to check if the temp of left not equal our temp of right. So we are going to return false. Else we are going to increase the left pointer and decrease our right pointer, and then we are going to return true because it's the code arrived if the iteration is if the compiler arrived here. So this is a right palindromic string. So we are going to pick what we are going to pick. We are going to pick this result, this temp inside already defined result variable. So we are going to push back this temp, and then we are going to recurse here, like we are going to solve the smallest we are going to resolve the sub problem from starting from this position. So we are going to pass I plus 1 because we already solved it I. So we are going to solve I plus 1 and then passing the items again, and we are going to undo our result to free space for the another scenarios. So we're going to pop back, and this is our do scenario, and this is our pop. So let's run this code. Don't forget to add a semicolon. Okay, let's pass AAB as example, or let's use let's use all test cases. All right, let's accept it. Let's submit and get accepted. All right, we get accepted. Thank you for watching the coding show.